Hello, folks. My name's Dasith. I'm a consultant working for a company called Telstra Purple, and this is a talk I did for NDC Sydney a few months ago. The recording from the official channel hasn't come out yet, so I thought I'll re-record it for the viewers of my blog and for anyone interested. So the title of the talk is called "Not All Microservices Frameworks Are Made the Same." And I've been working with distributed systems for a while, and as a consultant, I help development teams going through different phases of the distributed systems journey. I've worked with development teams who are going through a monolith to microservices transition and similar journeys, and I wanted to share some of my learnings. So this talk, not all microservice frameworks are made the same, about some mistakes I've seen in the wild and some of my scars as well. So as a primer, I want to frame today's discussion around domain-driven design. The key takeaways from this book by Eric Evans, you should read it if you haven't already, is that complexity around building software is understanding the business requirements properly. Don't spend too much time over engineering systems and then shoehorn business problems inside of those assumptions. You need to pick the right amount of complexity required for the problem. It's better to keep something simple with a path to refactor later than to over-engineer now. So these are some of the takeaways from the book and some of my experiences around good domain-driven design solutions. So having set this context, let's take a look at frameworks, or what I mean by frameworks. So frameworks can mean many things to different people. I did a GitHub search for repositories with keyword microservices, frameworks, and libraries, and these are the results. There were a few things that came up, and you might consider some of these frameworks, some of these not. Frameworks, libraries, or reference applications, they all can look very similar. What I consider frameworks, or what this talk refers to as frameworks, are all-in-one solutions that solve a broad set of problems using a prescribed set of patterns. Libraries, on the other hand, in my opinion, only solve a specific problem with a small scope. That's what differs them from frameworks. Reference applications, which is another thing, give you an example of how to structure your design. It's not something you can use everywhere, so you still have that scope for creativity when using a reference application, and you apply that to your problem. So let's contrast them, frameworks and libraries. How do you determine what is a framework and what is a library? The simple answer is, with frameworks, the framework calls your code. With a library, your code calls the library. Frameworks try to frame a high-level problem and provide developers the ability to customize the solution within the scope that it defines. Think how you would use your food processor in the kitchen. Now, contrasting that to a library, they solve a very small technical problem with no emphasis on what happens outside of its opinions. You can chain multiple libraries to solve a business workflow in your application. So yeah, unlike frameworks, libraries play well with each other. Compared to a food process example before, libraries can be thought of as different types of utensils, knives, a grater and a peeler, compared to the food process example before. Libraries are lightweight tools that are generally better than one heavyweight tool. And how do we end up with these heavyweight tools? I mean, no one intentionally makes bad choices, right? How do we then end up with frameworks? Well, in my experience, there are two paths that lead to these frameworks. They both are a result of over-engineering, or over keen teams to engineer best solutions for imaginary problems based on often speculation and results obviously in accidental complexity. Big design upfront is more often than not based on assumptions which turn out to be false as we learn more about the domain later. I want you to take this message home. You, you will eventually learn about the domain uh, better than you thought you did at the start. And the best place to take decisions is when you know a lot about the domain. So don't try to over-engineer things at the start when your knowledge of the domain is at the least. Um, so reinventing the wheel. This happens when your over development teams try to abstract business problems too early. We end up creating frameworks based on false assumptions, like we spoke about before. Then, when the domain understanding eventually evolves, we bend and twist our business problems to work with the frameworks we created before. It's the classic problem. You have a framework, you now try to twist your problems so that the framework can solve them. The other way we end up with frameworks, of course, is when teams decide to use a ready-made framework that solve many problems. It's something that might be used in the industry. You know that it can solve many problems, but then you invite over complexity to your solution to solve a small set of problems at the start. This is similar to putting a V8 engine in a lawnmower. Sure, you can do it, and it might work, but you will end up spending more time maintaining the engine than you actually to cut grass. Not something you want to do in the long run. Um, Bike shedding. So this is one aspect of frameworks that uh, is really counterproductive to a productive counterproductive to agile team or a team that wants to get results out there fast. Frameworks make us spend too much time thinking about abstractions to build our solutions on top of. This takes our focus away from solving the actual domain problem. So you'll see a lot of development teams arguing or talking about solving very small problems when they all agree 90% about how to solve how a particular problem must be solved. That extra 10% is where all the argument is and all the effort goes to. And frameworks generally invite this sort of bike shedding conversation. So the the easier it becomes when you don't try to invite frameworks to your solution at the start. Similarly, scope for creativity. Because frameworks prescribe the solution to a set of abstract problems, it's hard to use your creativity to solve something uh, in a very intuitive way or a way that makes sense to the business. This limits the capacity of your developers to solve problems in creative ways, and you end up with these cookie cutter solutions, which might not sound bad at the start, but what it means is you don't fully utilize your understanding of the domain or your experience. And your solutions might not be most efficient or precise for your problem either. So the next problem with frameworks is frameworks generally target one or two languages at most. This means your development team can only use these languages to build microservices with the framework. For a dynamic, evolving, agile team, this can be very limiting and can slow down your team. Imagine picking a framework and then not being able to use a right language or the a set of languages you want for the problem because the framework doesn't support it. Microservices are all about agility and the choice of the right tool for the job. Frameworks generally don't allow you to do that. Also, frameworks have a plethora of components. Remember, they try to solve all the problems under the sun. And generally you won't need 90% of what a framework provides. Using a poorly composed framework, which sadly most are, can cause large dependencies. And these dependencies are often larger than your own solution, which results in slow startup times, build times, etc. Even if you write your own framework, this is mostly true because you share that code across, uh, let's say, your services or microservices, and not everything will need all of the parts that the framework provides. And this forces you to share code between your microservices, which is another thing you don't want to do probably. Um, the frameworks also are designed to be all-in-one solutions. We spoke about this a couple of times before as well. They are not extensible because they are not built to be extensible. You have to shoehorn your solutions inside its opinion or the opinion of the authors of the framework. Uh, you either do it the way the framework's meant to solve that problem, or you don't use the framework at all. Uh, the components of a framework are generally very tightly coupled and engineered to be used in a certain way. And if you try to extend that or customize it, then you might find that the framework breaks down. Uh, as a result, the frameworks generally don't work well with other frameworks. I've seen this a couple of tweets by, I guess, industry experts, if I can call them that, about frameworks, and the general consensus here seemed to be that um, frameworks provide diminishing returns as the solutions grow. A simple to understand system, on the other hand, ages very well compared to a over-engineered one with a framework. So if it's a very short project and you want to deliver something very fast, maybe use a framework, maybe for a POC even. But if you want to maintain that in the long run, easy to understand system um, is much more easier to evolve. And this is generally true and aligns with my experiences as well. So, um, what does that mean for microservices? Does this mean that we need to solve everything? Uh, because building distributed systems are hard, and we don't want to reinvent the wheel when it comes to things like network engineering or network layer problems, because they require expert level knowledge. It's easy to make false assumptions about the network layer in your distributed system. Uh, so if you don't want to reinvent the wheel here, how do you solve these problems without using a framework? So luckily, there's a solution. You can use runtimes or platforms. This is another thing that's different from frameworks. They don't prescribe how you solve your business problems. This gives you the ability to use any language or tooling, be agile, still leverage a platform underneath to solve the distributed system complexities. So you solve the business part of it. The runtime and the platform solves the network layer and the distributed system complexities. So let's look at a couple of examples. Um, so I'll start off with the differences before we look at the examples, because it's important to understand how they differ from frameworks. The focus of the two is very different. Frameworks are prescriptive about how you solve a particular problem, and it can affect how you express your domain problems. Runtimes are agnostic, on the other hand, about your programming language concepts. So you can layer your own concepts and your business problems, solutions on top of that, and use the building blocks the runtime or the platform provides. Flexibility, like discussed a few times here, uh, frameworks provide all-in-one solutions. Most frameworks have a bunch of magic that only works correctly if you use every component the framework provides. There's very little piecemeal approach here. Runtime or platforms, on the other hand, are mostly invisible to the domain, and you don't require total buy-in as a developer. This allows you to express your creative freedom and leverage advanced features of a runtime. Um, and as your solution grows, the advantage you get from a boilerplate provided by a framework, this is going back to those tweets as well. See, remember how they tend to give you diminishing returns as the solution grows and ages, and often can be counterproductive as well. When it comes to runtimes and platforms, because they don't interfere with how you express intent when solving domain problems, the code doesn't become unnecessarily complex or bloated. When using runtimes, distributed system complexities, this is important. The distributed system complexities are decoupled from your core logic. So you can subsequently upgrade and maintain a runtime separately. This improves overall maintainability of your software solution. So what is an example of a runtime? Uh, Dapper. So this is the distributed application runtime by Microsoft, a fully open source solution. It's fairly new, I think about 12 to 18 months. Event-driven portable runtime for building microservices on cloud or edge. It's got full support for running on Kubernetes or in a self-hosted manner. So you can run it on any cloud, any vendor, AWS, Google, Azure, even in your own data center. It's got a rich set of building blocks you can choose to develop your microservices. And this is I guess, a overall picture of how Dapper sits on top of an edge or a cloud infrastructure, provides you with these building blocks, which are then exposed through a portable HTTP or a gRPC API to any language of your choice, as long as it can talk HTTP or gRPC. Even if a new programming language is invented today, Dapper can work with it. So the way Dapper works is by providing these building blocks. These are abstract features that you can kind of use as uh, pieces to construct your business logic. They don't enforce how you solve a problem. It's just that these are things you can use for common tasks that you would do in a microservice. And the way Dapper does that is through having components inside the building blocks. For example, let's take the actor model building block. It's got a pub sub component and a state component. So these components, you can then have them plugged in during the deployment time. So if you're using the actor model building block for your microservice, during the deployment, you can actually choose which pub sub implementation, whether it's Redis streams, Kafka, Azure Service Bus. You can use RabbitMQ when you're developing locally, and then Azure Service Bus when it's deployed in production without changing any code. And this is the nice thing about having this abstract building block and component model in Dapper. So what about platform? So Knative is an example of a hosting platform. It takes your existing container workloads and allows you to run them on top of Kubernetes and Knative without having to worry about infrastructure concerns. It extends Kubernetes through a set of middleware components. You can pick and choose the right components you want to use. Your containers don't need to know anything about the platform. You simply talk to a container through the logical naming convention. It does all the network traffic routing, load balancing, everything like that. So in the overall picture, this is where the developers sit. You simply use the Knative API to talk to it, and you can deploy and run stuff there. The two main components of Knative are serving and eventing. Um, the serving component is the one that handles the network engineering, auto scaling, revision tracking. The eventing part allows you to have some advanced things like universal subscription delivery, etc. But the the good part about this is you just have to focus on your core logic. The platform will handle the difficult and boring bits like network engineering and scaling. Uh, so, what are the conclusions? So, the key takeaways I want you to take from this talk today is that simple solutions are easy to maintain and make sense of. Composable designs allow us to pick the right tool for the job. Um, Please stand on the shoulders of giants. I've got another talk that I did at API Days in 2020, where I go into detail about why you should leverage the giants of like Microsoft, Google, or Netflix. Leverage the runtimes and platforms they provide, so you don't have to solve the distributed system complexities because they are really expert level problem. You don't want to be solving those when you're solving business problems. You please use a appropriate level of engineering for the problem. Don't uh, try to solve imaginary problems. Think about the people, the poor people who have to maintain what you build. I'll leave this quote with you. This is some how I feel when I'm learning about microservices and that, and I'm implementing microservices. I never feel like I've mastered it if I learn about something I didn't know about every day. So there's no perfect way to build a system. Hindsight will always make you look stupid. Set yourself up to correct your mistakes in the least obstructive way, and this is why using frameworks is not the way to go. Um, Friends don't let other friends use microservices frameworks. So thanks for listening to my talk. I'll try to upload the original recording when NDC Conferences uploads it to the YouTube channel, but if not, I'll probably leave you with this, and thanks for listening to my talk.